Hi everybody, in this video we will use trig identities to simplify trig expressions. The overview of this idea is that we're going to take reciprocal identities, quotient identities, Pythagorean identities, and even and odd identities, and we'll use those to rewrite and simplify trig expressions. Simplifying trig identities is different than verifying trig identities. When we verify trig identities, we know what the left and right side should be equal to. When we're simplifying trig identities, we don't really know what the answer is until we get to the last step. We'll start easy and build from problem to problem. Our first one says sine squared x plus cosine squared x when x is equal to 72. This is a nice place to start because sine squared x plus cosine squared x is a Pythagorean identity which we know is equal to 1. Knowing the value of x doesn't really matter. Sine squared x plus cosine squared x will be 1 regardless of the angle. The only thing we need to say for this expression is that it is equal to 1. Our next problem is a little similar. I have sine squared x plus cosine squared x over secant squared x. Sine squared x plus cosine squared x will still be equal to 1. On the bottom, I still have secant squared x. We can rewrite secant squared as 1 over cosine squared x. When I divide by a fraction, I multiply by the reciprocal. We'll write this as 1 times cosine squared over 1. We can write this as cosine squared x. Our next one says cosecant x times tangent x. Let's rewrite cosecant as 1 over sine x, and we can write tangent as sine x over cosine x. The sine x cancels, so I'm left with 1 over cosine x. 1 over cosine x we can then simplify to secant x. This time I have a quotient of cotangent x over cosecant x. Just like the last one, I'll start by rewriting these. Cotangent x will be cosine of x over the sine of x, and I'm going to put those in big parentheses, then divide by another set of big parentheses. Cosecant is 1 over sine x. We can rewrite that as cosine of x over sine x times, I'm going to flip 1 over sine to be sine x over 1. I'll cancel the sine, and my final answer is cosine x. Here's another ratio, but it got a little bigger. In the numerator, I have tangent of x, which I'm going to leave for now to keep things easy. I'm going to concentrate on the denominator that has two terms. The first term, secant, can be written as 1 over cosine of x. Then cosine, I'm going to write as cosine of x over 1. What I need here is a common denominator. Since cosine of x is in the first term, I'm going to put cosine of x in the second term. It means I want to multiply the top and bottom by cosine of x. This says I still have tangent of x in the numerator, but now I have 1 over cosine of x minus cosine squared of x over cosine of x. We'll keep the tangent of x. I'll combine the two terms in the denominator. I have 1 minus cosine squared over cosine x. If we think back to our Pythagorean identities, we know sine squared x plus cosine squared x is equal to 1. That means sine squared x is equal to 1 minus cosine squared x. We'll make this substitution in the problem. Now I have tangent of x divided by sine squared x over cosine x. Let's rewrite tangent as sine of x over cosine of x, and let's multiply by the reciprocal of the denominator, which is cosine of x over sine squared. The cosine x cancels. One of the signs cancel with one of the signs in the denominator. My numerator is now 1. My denominator is sine x. 1 over sine x would be cosecant x. Let me show you a second way to simplify this expression. This time we'll start by saying tangent is sine x over cosine x, and I'll put that in parentheses to keep track of it. And in the denominator, I'll say secant of x is 1 over cosine x and then I still have cosine x. So instead of finding a common denominator this time, what I'm going to do is clear the fraction within a fraction that I have in the denominator from this cosine of x. So I'm going to multiply the top and bottom by cosine of x over cosine of x. Anytime we multiply, we just want to make sure we don't change the expression. So multiplying by cosine of x over cosine of x is equivalent to multiplying by 1. Be really careful and make sure that you multiply every single term by cosine x. I'll do that the long way. So I'll have sine x over cosine x times cosine x. In the denominator, I'll have 1 over cosine of x times cosine of x minus cosine of x times cosine of x. In the numerator, the cosines cancel, and I have sine of x. Looking at the denominator, cosine x cancels cosine x, I have 1. Cosine x times cosine x is cosine squared x, and I have a minus sign between the two terms. The numerator stays as sine x, and we learned earlier that 1 minus cosine squared x is sine squared x. We can cancel one of the signs in the numerator with one of the signs in the denominator, leaving us with 1 over sine x. 1 over sine x becomes cosecant x. So that shows you there's more than one way to get to your answer. Which one you do really just depends on what you see as you're doing the steps in the problem. Our last one says cosine of negative x plus tangent of negative x times sine of negative x. Because this problem has so many negatives, it makes me think about the even and odd nature of the trig functions. Cosine is even. That says cosine of negative x is the same thing as cosine of x. Tangent is odd. The tangent of negative x is negative times the tangent of x. Sine is also odd. The sine of negative x is negative the sine of x. When we put together the negative from the tangent with the negative from the sine, we get a positive. Now I have cosine of x plus the tangent of x times the sine of x. Here I have the cosine of x plus tangent is sine x over cosine x. And then I have times sine x. Now I have cosine of x plus sine squared of x over cosine of x. Here's another problem where I need to have a common denominator. The common denominator will be cosine, so the left term gets multiplied by cosine of x over cosine of x. Cosine of x times cosine of x is cosine squared of x plus sine squared of x over cosine of x. Cosine squared plus sine squared is 1. 1 over cosine of x leaves us with secant.